Welcome back to my Monogame tutorial. Last time we talked about render targeting. We got that all set up and running. Everything went just fine, and in this part we're going to go more in depth into how the draw method works, and we're going to draw some more things. I'll show you some ways you can draw different things, how you can colorize them, and how exactly this works. So we're going to start off by going to the pipeline tool, and last time we created this folder here just for demonstration purposes, and we're going to add a folder within the folder just to show you that you can in fact do that. So we're going to say let's say backgrounds right there, and within backgrounds we're going to go and add an existing item. So we're going to add background.png, copy that, then we're going to rebuild. I'm going to save real quick. So now background.png is now part of the game, and now we have to code it. So we'll just do same thing as last time, text or 2D. Let's call it background 1. Obviously, if you were making a real game, you would want to use something more descriptive than background 1, because who knows what that could really be. Then we're going to go down here. We're going to copy paste because I like copy pasting code. Makes things a lot more simple. I'm going to refer to background 1 that we just created. Now we're going to do images slash backgrounds slash background. Alright, so now we've created the image and we've loaded it, and now we can go down here to draw it. So the important thing to note is it will draw things in order. So whatever you want in the very back, whatever you want as the background, you want to draw that first. So we're going to put it ahead of Stickman. So we're just going to refer to background 1. And for now, we'll just set it to vector2.0, which is the top corner, the top left corner of the screen. And this should run just fine. As you can see, instead of the very plain blue background, we have background with the word background all over it. Again, just for, demonstrating. Now, as you can see in the actual image file, it is 1080 in height, and we open that up. Background is repeated 4 times, and background is also repeated 4 times here. That means the render targeting is working just fine. We could tell that before by the fact that Stickman, he's shrunk in size, but you can see here that I guess you could say the internal resolution is 1080, while this actual window is 720. So now that we've done that, I'm going to show you real quickly how you can just colorize something. So if you have a black and white image, you want to make it a different color, you can just go ahead, change it from white to pretty much anything else, and you can see you can colorize it. Now if you're trying to save a lot of space, especially saving a lot of RAM, you can have one image and colorize it over and over again. So you can have all these variations, and that should save you some RAM because you're just loading one image and using it over and over again. And yeah, that's how you can colorize things. Now you're probably wondering, how do I get rid of the white background? Well, usually if you're making a game, you'll typically have an artist who will do that for you, but for this demonstration, what we're going to go ahead and do is we're going to go over here. Let's open the containing directory of Stickman. So this is our image that we're using in the game. I'm going to drag and drop it into GIMP right here. GIMP is a free program, by the way. I'm sure pretty much all of you know about it. And we're going to go use the paint bucket tool. We're going to fill in the white space around Stickman. Layer, transparency, add alpha channel. Sometimes that will be grayed out. If it is, then don't worry about it. We're going to select by color, select the green space, press delete, and there you go. Now we can overwrite it. Let's go back into Visual Studio and also back into here. We're going to rebuild this real quick. I don't think you really have to, but we're doing it just in case. And now the image should be transparent. There we go. So now Sickman does not have his little box around him. Okay, so now I'm going to show off different things you can do with this draw method right here. So we can actually refer to very specific things rather than what is shown here. So as you can see, there's a lot of different variations of this method that we can utilize. But something we can actually do is just kind of ignore all that and refer to these things directly. So we can do something like position, use a colon, we can use color, use a colon, and this way we can manipulate what we're drawing very specifically, whereas if we were to go and use something like this, we might not want to use all these. Maybe we don't want to change the origin or the rotation, but we do want to change the scale or use a sprite effect. And doing it this way will make it so you don't have to input a lot of default code all the time. So let's go ahead. I'm going to show you how we can use sprite effects. I'm going to do effects, sprite effects dot flip vertically. Now it's going to say that this is something like outdated code or you're doing it wrong, but it works just fine. Don't worry about it. And as you can see, we have the sprite effect taking place. We can flip things upside down, or we can flip them horizontally as well. And something that you probably won't be using too much is scaling with individual sprites. Now this is something you would do if you weren't using render targeting, but let's say we just set scale as 2. Actually, hold on, it has to be a vector 2. Then we can set it to 2. So now it should be twice as big. Yep, there we go. So you can actually be very precise with this. You can do, you know, 2.54. Just make sure you indicate that it's a float, because vector 2 only takes float. And you can be very precise with how much you want to scale it, but you don't usually need to do that. Maybe if you're trying to make something, you know, grow and shrink, something along those lines. Otherwise you won't be using that too much. Now there's a lot more things we can do here, but we're going to save some of that for later when we get into animating sprites, because draw method has some built-in stuff for animating sprites, but we'll get into that later because it's a lot more complicated than what we're currently doing. For now, we're gonna get into having the sprite go somewhere other than the default position of vector2.0. So we're gonna create our own vector2, and we're gonna name it I don't know, player position. I just use POS for short. And under the update method, we'll actually get rid of this real quick. This is default code when you start a new Monogame project. We'll create our own input code later, but for now we're gonna do player position equals new vector2, and then we can do let's say we want it to be 200, 200. This will set them a little further along. And for player position, we're going to go ahead and replace this. And we're going to go ahead and run that. And as you can see, he's a lot further inward on the screen. Now, let's say you want to center something on the screen. I'm going to show you how you might think you should do that, but you probably shouldn't. So we're going to go and look at the x coordinate, which is the horizontal one. We're going to do render target dot width divided by half. So it will take how wide it is, divide it in half, and put the stick man right in the middle. And we'll do the same thing here. Render target dot height divided by 2. And let's go ahead and take a look. And as you can see, the stick man is roughly in the middle, but not exactly. And that's because for images, the position is determined by the top left, which means the top left is centered, not the actual image. So to center the image with the center of the screen, we have to do something a bit more complicated. So we're going to deduct the actual width of the sprite divided by 2. So we'll do stickman dot width divided by 2. So we got a bit of algebra going on here, and we're going to do the same thing right here. We're going to deduct stickman dot height divided by 2. So this will take half of its height and then adjust it accordingly. So now it should be very, very center on the screen. There we go. So that's how all the coordinates work. I'll show a little thing on screen now that will show how it actually works different than you probably learned in like high school math class or middle school math class. The y and the x do not work the same way. Y, the number goes up as it goes down toward the bottom of the screen, and the x goes up as it moves to the right. I don't know exactly why they decided to do it that way, but after a while it's just something you get used to when you're making a game. You think of the coordinates a little differently. Now let's talk about actual movement and frame rate. Now we'll get a lot more in depth into actually controlling the game and doing things like that, using game pads, using different keyboard configurations, things like that. But for now, we're just going to do something very basic just to start off. We're going to do keyboard state. We'll name it key state. This is just an example because we're going to need something on screen actually moving so we can see how frame rate works and how we can alter the frame rate and how we can separate how the frame rate works from how the game actually runs. And yeah, we'll just we'll continue with this. I'm gonna do equals keyboard dot get state. So this will get the current state of the keyboard, what's being pressed and what's not being pressed. Then we'll do an if statement. We'll do if key state dot is key down keys dot, I don't know, let's say right, which is the right arrow key. We'll do something like player position dot x plus equals, let's say 1. So it'll move pretty slowly, but that's what we'll do. We're going to quickly move this up here to the load method, and that's because update is called very consistently, so it would just keep resetting the position every time we would try to move, so we don't want that. We're gonna run this real quick. I press right on the arrow key, And Sick Man moves a little bit. Very slowly, but he moves to the right when I press right. Now what we're going to do is we're going to talk a bit more about frame rate, a little bit how update and draw work. So we're going to pull up a program called Fraps. It's a very popular program. I'm sure you've heard of it. Fraps will tell us the frame rate of the game, which is currently 60. That's the default for Monogame, for most games in general. But right now, what if we want the game to go at a higher frame rate? Because, for instance, my monitor is 144 Hertz. So what if I want to play a game and have it be really, really smooth? Well, there's something we can do for that. Go to initialize, and before base.initialize, we're gonna do something. We're gonna do target elapsed time. Now, target elapsed time, as you can see, it references game span, time span game, and of course, game, as we can see, is part of the XNA framework, as I showed before. Target elapsed time equals time span, and we're gonna have to use the little light bulb here. Using system, which gets added up here. So if you have an older version of Visual Studio that doesn't help you fix things like that, you just do using system up here. I'm gonna do time span dot from seconds. Then we're gonna do 1.0 divide by 144.0f. And what we're doing right now is we're targeting 144 frames per second. Let's run that real quick. And we can see it's now running at 143. It's one off because of VSync. Now, I recommend you don't mess with VSync. If I were you, I would just leave it on all the time. Now, the last time I checked, there were some pretty nasty bugs with the Monogame engine when you messed with VSync too much. Like if you turned it off and on over and over again, it would freak out and just not work at all. So if I were you, I would just leave it on all the time. I haven't had any problems with just leaving it on. But there we go. So it is now 143 frames per second. Most people, actually, probably nobody can tell the difference between 143 and 144. So this is good. This is what we want. Just gonna close that right now. And now we're gonna do something called fixed time step. So we just type in is fixed time step. We're gonna set that to equals true. And what fixed time step will do is it will use update consistently regardless of what draw is doing. It will try to draw frames as much as it can to match that 144, but update will always go at 144. And this is good because we don't want the game to be frame rate dependent. I've seen it all too often where a game, it's on PC and you should be able to run it at 60, but they made it for consoles first and then ported it to PC, and it's locked at 30 frames per second. And they can't change it because they coded it to be frame rate based. And if they increase it to 60, it would speed up the game. And so hackers will be like, oh, well, it's 60, I'll just, hack it to make it a higher frame rate, and it speeds up the game, and then the physics don't work properly. So what we're doing here is we're kind of separating how the game runs and how the game actually renders things. So that is now separate because of fixed time step, and also now the frame rate is higher. Now if we go ahead and run the game again real quick with our higher frame rate, we can see that Sick Man is moving a lot faster than before. That's because the game is now running at 144 regardless of what it's actually displaying. Now I want to show you real quick that since we have VSync actually on, it will render things at the same frame rate as the monitor. So we're gonna go to display settings real quick. Advanced display settings. This is the monitor I'm using. We're gonna lower it all the way down to 60. Apply that. I hope the video capture doesn't mess up too bad. And once I do that, we run the game. It's not running at 60, but Stickman moves just as fast, which is great because we want it so no matter what kind of monitor they have, the game will run the exact same and it will be equally as responsive. But if we want it to be truly independent of frame rate, what we'll have to do is we'll have to add sort of a time factor to everything. So let's go on to our update method. Actually, before that, I've nearly forgotten, but we want to create a new float right here. And we're going to call it time passed. And we don't have to assign it any default value. And the first thing that's going to happen every time the game updates, which is 144 times every second, we're going to have it calculate the time that's passed since update last ran. So we're going to do time pass equals, let's see, game time, which is this right here. I'm going to do dot elapsed game time dot milliseconds. Make sure it is milliseconds, not total milliseconds, not seconds. It's very important that it's milliseconds because update is being run so frequently that 0 seconds has passed, and total milliseconds is total milliseconds since the game has ran. So we're going to do that. Then we're going to create a new float, and we're going to call it movement speed. And it's going to be equal to time passed, and we'll divide it by some number. Let's say 2.3. Actually, 2.38. That's actually, after a lot of experimenting and testing with games, I determined that's about the fastest I could make it without causing weird issues with hitboxes. Although afterward, I then figured out how to fix those issues with hitboxes regardless of how fast you were going. But for now, we'll just go with this seemingly arbitrary number. And now we'll replace that 1 with movement speed. So now the movement speed is based off of, yeah, it is now based off of time passed rather than frame rate. So real quick, we're actually gonna set the monitor to go back to 144. Not that you can tell the difference because YouTube only goes up to 60 and this video will probably be rendered in 30 frames per second. But I just wanted to change it back real quick. We can see how the game reacts. Now what we're gonna do is we're gonna experiment a little bit. We're gonna change this back to, let's say, 60, which is the default frame rate. So we do that. It is now 59, close enough. And we can see that the Stickman moves just as fast, whereas before, when it was 60, it moved a lot slower. So now, no matter what the frame rate is, no matter how much everything is lagging, everything will go at a consistent speed. All you have to do is add some kind of time passing factor to everything that moves in the game. And that's going to be it for this tutorial. So we covered more about sprites, drawing sprites, we did some effects with them, And we also discussed fixed time step. I showed you how to increase or decrease the frame rate, and also how to separate the game running from the actual frame rate itself, so you can have it run at whatever you want. And next time, we're actually going to go into controlling things, how to use the gamepad, how to use the keyboard, and even how we can set up the beginnings of mappable keys, how we can make it so the user can determine what key does what. So thank you for watching, and come back next time and I'll show you a whole lot more about Monogame.